Hi there, I'm Surge Psych. Welcome to my YouTube channel.
Hello fellow YouTubers and welcome. This is going to be just an informal talk about the rolling command station that we've built for the North Texas T-Track Modular Train Club. This build pertains to anybody utilizing an N-scale or HO, possibly O-scale layout. We do have up to 18 volts dedicated to this track power, so I appreciate you coming to visit to check out this build. Let's get started. We're going to have a video series of a few different construction videos. The first one will be including 1 and 2, which is the upper box construction and the power input construction. The subsequent series will include main component placement, electrical connections, and power district connections. Basically, we decided to build this rolling command station for one really main purpose, and that's to simplify the electrical setup and breakdown of our layout. We do have a T-track layout. You know, and it's not a horribly long layout like some of the clubs I've been in the past where it's taken 6 or more hours to set up. But still, when you're talking about small layouts, or I guess even moderate size layouts, to get the electrical aspect connected in a timely manner, it's always somewhat of a challenge. So that was our main goal. Our other goal was that we wanted to be able to control both DCC and DC with either our club Digitrax controllers or a smart device, iPhone, iPad, Android, whatever's out there. And with this setup we can actually do this all wirelessly. We have the rolling command station set up to use 4 DCC blocks. Each connected block is separated by those black Kato Unitrack isolators. But basically, if we run an entire loop, it's all connected. Otherwise, we'll probably have our yard separate from the main layout for functional purposes, obviously. It's also set up to use up to 4 independent DC blocks. Right now we're currently utilizing 2 of those blocks. I do have all 4 of the Anderson power poles connected in there for future use if we decide to upgrade up to 4. Right now, only having 2 of them is really all we need for our purposes at this time, and they're powered with a 5 amp G-scale DCC decoder, and I'll explain that in the later video segments. Again, as I mentioned previously, we're currently running about 15 to 18 volts to the track consistently. Here are the main powered components, everything that's within the top portable box. You can just review this at your discretion. I'm not going to go over everything, as I'll be going over everything through all the other videos. So let's get started. Let's talk about the upper box construction. Well, before we decided on doing this build, everything was packed into just really 2 disorganized carriers. Everything was just chunked in the toolboxes. This was the first of the 2 toolboxes, and this was the second toolboxes. So it was a mess. And then with all the expensive electrical components, you just want to take care of that stuff. Once we got set up on the layout, this is how our components were kind of just placed on the tables where there was free space available. So no real structure there. But here in the end is what we're going to achieve. This is actually what the final build looks like. It's completed. Works amazingly well. Nothing blew up. After an initial faux pas, but that was my fault during the build, but that was easily remedied with just a couple of reversing of the wires, and then taking it to the layout the first time. Of course, I tested it all at home, and then taking it to the train show. Everything pretty much went without a hitch, so it was really nice to see that. Really nice to see train club members who are used to using their Digitrax controllers being able to just put their trains on their DC trains on the layout and run through their controllers. It was it just makes it more simplified in that regard. So what first? First, you got to find a toolbox. I found ours conveniently, surprisingly, in an antique store. It was just in a junk pile, and they just wanted 20 bucks for it. It was all muddy and dirty, but I just brought it home, cleaned it up. Online, it retails for about $150. I think you look under Stanley Toolbox or Staley Toolbox. I've seen them for sale at Walmart. Still on sale at Walmart as of 2018. So you may be able to find one cheap somewhere if you look around or go online. Of course, like I said, it retails for $150. It's a little out of our price range, and that we just happened to stumble across it was just a bonus. So that's when we decided to actually do the build, because we found a cheap toolbox. And of course, get one that fits your club's needs. They come in different configurations. So over the series of these videos, we'll talk about that. We'll different sizes of toolboxes, but all of it can basically be customized with these basic components within the top of the box. So here we go. Got it home, cleaned off all the dirt, and it can be broken down for portability, not only during travel, but if you have a club member who can't carry that much weight just due to handicap or age. It's kind of nice to be able to break it down to fit it in a van or a car or a trunk, whatever. The head can be removed anywhere onto the layout, independent of all the other box components. It will, however, need to be plugged into a power source. Let's get started building the mast first. That's where I started beginning initially. I used foam to make a template for the removable electronic board, which you'll see later, which is made out of MDF, but as you can see here, I just made it out of styrofoam, which I had laying around. There's 3 sections of PVC that were used and cut to fit in a folded manner. The UR92 head cover and a flagpole holder, of course, are attached at both ends. And it's all interconnected with a tent pole shock cord. It's flexible, stretches, so you can pull apart each section and then fold it in that manner. That was Vic McTee's idea. So first we worked on getting the mast to fold and unfold properly, and then this is kind of the idea of where I wanted it placed, because it just made sense as far as where all the other electronics were going to reside within the box. And this with the UP5 in the back, the mast folded over it quite nicely, and with room to spare on top, so it wouldn't. The box, of course, covers the UP5 so it doesn't damage it. We go folding the mast or piecing it together. I used a flat PVC cap within the UR92 box and drilled a small hole big enough for the shock cord to slide through, and then I knotted the cord at the top so it's really low profile within that box. A piece of PVC was inserted into the flag mast with the stock screw holding it in place. I drilled a little hole inside the PVC here so that when you screwed in that stock screw, everything would be secured in place and without wiggling around pretty nicely or turning for whatever reason. So we need power. I got this little box on eBay. It's a 20 amp power box, has a 15 amp socket adapter. It's all 14 gauge with a 50-foot extension cord. To get the power into the box, I had to install a C13 power switch. Be aware there are two varieties of these switches. Know which one you purchase for proper attachment of your power, which we'll go over here in a second. This is just for informational reading. I don't know if that'll show up too well or if you can zoom in somehow on your screens. It just digitracks information. It regards the power during my research for all the power supplies of all the components that we use. So it was kind of a one-stop shop for me to see, okay, what do I need to do to, you know, get the right LED driver to power everything. And that was the basis of that research. So first, we look at the bottom of the box. I needed some space to fit all the electronics from the bottom of the box to where the electronics are going to be mounted underneath. So I figured out that 20 millimeters was a good distance from the bottom of the box to the MDF board. So I got me a little miter saw and cut a dowel into 20 millimeter lengths for the feet. And then once I got the template on the MDF board off of the styrofoam and placed it in there, then I sort of did a mock-up to test the fit of all the components that were actually going to be in the box. I ended up getting a lower profile Digitrax DCS 210 power wart to replace this giant brick that we had previously. This is not the final component placement version, so I changed things up a bit towards the end just to get things to fit a little bit better, and you'll see that in the other videos. But this is our future goal. This is pretty much what everything's looking like. There is a little MDF shelf that covers this to protect all these units where the power source actually lies on top of that. I'll go back a slide so you can see that. You see how this board overlays to allow the power wart to lay on top. So that's what that's in place for. So let's get some power into this box. We need to cut holes for the power and the UP5s. I started with UP5 access. I made some templates. I made 2 templates from the UP5. All measurements are in millimeters. The left template cutout is 20 millimeters from the top, 10 millimeters from the side, and 15 millimeters from the bottom. The right template was traced from the fascia plate itself. Drew my cuts and used number 6 screw holes. Here you see after I've finished cutting both sides, the UP5 fits in there quite nicely. It's in millimeters. You get such a precise fitting. You know, it's hard to mess up. Mark the electrical board, the MDF board for fit and cut, and then check the UP5 with the covers on. So I put the covers on. You can see the tracings. Cut them out and then put it back in to make sure everything dropped down in and dropped out, because this board has to be removable in order to access any electronic components in the event that something needed to be changed out or replaced over many years. Final views from the front and back. There's your UP5s, electrical input, with the handle in the up and down positions. Everything's looking good so far. Next we're going to do the power plug. The template for this one is 48 millimeters long by 30 millimeters wide. Bottom corners were cut at an angle to accommodate the switch dimensions. So here's the power inlet cutout complete. Be careful that the Dremel disc does not get too small, or it will just fly right off that thing. So wear eye protection absolutely when you're doing this. After I was done, I buffed out all the sharp edges with the little metal Dremel brush, and that was on both the UP5s and this. After the relief is cut, place in your outlet, and you can see where the screw holes line up. And of course, after you're done, before you put any electrical components in here, and what I had to do is every time I started dremeling or whatever, I had to remove the UP5 just so that no metal shavings got onto those items. So just be aware if you're watching this video, I would do all your cuts and then vacuum everything out and then put in the electrical pieces back in. Electrical baseboard construction, and this is how everything is wired. This is how the jumpers look. This was my reference point. The power strip, I cut off the plug. This is actually the first run of the power strip. I cut this one too short, so I actually had to use a different one and keep the entire length of the other one. And all I did was cut off the plug. And very carefully, you strip the outer sheath of the cord. I used a box cutter. And was careful not to cut the main wire, so it's just kind of a feel. And then if you spin the outer sheath, once you have the cuts, it'll just twist right off. Then you strip the main wires and place female connectors according to the orientation on the switch. Here we go with everything plugged into power. The bottom to bottom is ground. It's a green wire. Your top left to right right side upper is a switch for the jumper. Top middle to the hot load is black. Top right to neutral is white, and it's combined. Top right and right side lower wired together under the same connector. With this configuration, and you'll see on the next slide a different view, this configuration will light the light switch only when power is applied. Once the power is pulled out of the wall, the light shift will turn off, but still you'll have that to toggle that switch off or on, and when the box is on, this light will be on as well. Here's a different view just for reference. I did dab a little white acrylic paint here, some green here, and some white here to identify where the plugs were going to go. Once I got back to this, once I got to putting in the power for everything else. Let's see, with the plugs removed, you can mark your removable board to cut out a relief, so later you can lift the board straight up and out. So what I'm saying here is that once you have your power in there, you can actually, what's going to happen is you're going to remove your plugs and then see where the cut is going to go on this MDF board. So when you lift the MDF board out again for future reference or future use, it can clear this wire here without getting caught and tilting or whatever, because you're going to have components all on this MDF board. That concludes the first video series. Feel free to email me for any questions. When you email me, just put in the subject heading NTTT RCS question, and you can email me directly at my email address. Again, I'm with the North Texas T-Track Modular Railroad Club. I appreciate you watching these videos. If you do enjoy these videos, give a thumbs up so at least I can know what kind of feedback that's out there. And we'll see you at the next training session, where we'll talk about the main component placements. Feel free to leave a comment if you'd like. I'd like to hear your thoughts, and I appreciate you again watching these videos. I mean, I'm not the best speaker in the world, but I think at least what I have to offer for train clubs and the opportunity to simplify setups and stuff, I think these videos will be very helpful. So good luck. Thanks for watching. We'll see you next time.